Hello, everyone, and thanks a lot for joining our webinar for Web UI testing and Python with Python and with Lambda Test platform. Thank you so much, everybody, and thanks for your patience as well. And I'm Jay. I'm one of the founders at Lambda Test, and I will be your host for this webinar along with Andrew Knight. And then just to give introduction about Andrew, Andrew, the Automation Panda himself, and is an international speaker who has given notes at multiple Selenium and Python conferences, in fact. And he brings in a decade of experience in development and automation testing space. And also, Andrew specializes in building test automation suites from the ground up. And also, one of the interesting facts about Andrew is that he likes writing and sharing his knowledge and has an informative blog named automationpanda.com. And I would highly recommend you guys to check it out if you want to know more about automation testing, Python, and development in general. And great. So, and now wanted to share a quick overview about Lambda Test, who we are, and the agenda that we'll be covering. So Lambda Test provides cross-browser testing cloud, and we are basically building a test execution infrastructure on the cloud. And today, as of today, we have around 2,000 plus combination of browsers and operating system on the cloud. And with this, having said that, you'll be able to perform Selenium automation testing, where you can plug in your Selenium automation test scripts to our cloud. And we also support 32 frameworks that support Selenium scripts like Nightwatch, and you can say Protractor and many other. And you'll also be able to run the CI/CD tools, run your test directly from CI/CD tools as well. And we have a thorough documentation on the same, and I'll be more than happy to answer any questions as we go along. And with that, you can also perform live testing, responsive testing, and screenshot testing. Today, we have around 100,000 testers and developers across the globe who trust our platform to perform cross-browser testing. And like I said earlier, we have tight integration with project management tools as well for one-click bug logging. And you can also run your schedule and run your test from CI/CD tools. And apart from that, one of the major differentiating factor about us is also 24/7 support. And if you face any challenges as we move along, and if you want to give Lambda Test a spin, you can kind of reach out to us through our chat support. And we also have a lifetime product access freemium plan as well around our product. So this is a quick overview and about Lambda Test. I don't want to take too much of time here. I think most of the things that Andrew would be covering up on how you can leverage Lambda Test as well in running the test. So today's agenda, we would be covering how you would perform web UI testing and an overview of the same with Python. And Andrew will also help you out how you can write your first test, and also how you can make browser interaction and run parallel tests across multiple browsers. And post that, we would also be happy to answer any questions that you might have. And yeah, over to you, Andrew.
Thanks, Jay. Thanks for a great introduction. And hello, everyone. Let me share my screen here. Jay, do you need to yield control or anything?
No, I think you can share.
Okay. Okay, boom. Share my desktop here. Thanks for your patience, everyone. And slideshow, current slide. All right, can everyone see my screen okay? Cool. So let's make web UI testing easy. To start off with, I'd like to let everyone know the example project that we'll be using today is hosted on GitHub. It's under my user account, EddyLPK247, and the name of the project is Lambda Test Python Web UI Testing. After this webinar, feel free to check out that project, clone it, try to run it locally with your own Lambda Test license, and you could even use it to extend it with new tests so you get some better practice. So let's talk about what web UI testing actually is. When I say web UI testing, I'm talking about black box testing of a web application through a live browser. This is very different from, say, unit testing that is testing code. With web UI testing, we're testing features. We're testing features just like a human user would interact with your web application through a browser like Chrome or IE or any other such browser. What makes this type of testing powerful is that it is truly end-to-end. Even though our testing and automation will interact primarily with the browser, with the web UI, the entirety of that app is indirectly tested because the stack needs to be in place for that web app to be served. So we're testing not only the web UI, but the service APIs behind it, any persistence layer of databases, any load balancing, any worker threads, everything and anything that goes into that web app will be touched when we interact with the web UI. However, web UI can be a bit of a challenge. Automating web UI tests takes a bit of expertise and a bit of time. They also have a notorious reputation for being flaky. And many times that's not necessarily because the web application itself is flaky, but rather within the automation code, we don't always appropriately handle race conditions or the dynamic changes on a web page. So with these challenges, we always want to focus our web UI testing efforts on getting the highest return on investment for the time we spend doing it. We don't want to necessarily test all the things. What we do want to test are the important things. So any sort of lower level code, we should be testing at unit and integration levels. And when we do automate web UI tests, they should be on important individual behaviors. So maximize the ROI, maximize your testing like a user would be doing it. Let's talk about the solution we'll be implementing today. Test automation is software development. I want to make that very, very clear. It's just a different domain of software development. It's not a front-end system, it's not a back-end system, but it's still a system nevertheless. And so we need to treat automation development the same way we would treat any other software development. We need good practices, we need to follow good design patterns, we need to go through code reviews, the whole shebang-a-bang. So here's what our stack looks like for the solution we're going to make today. Our language of choice is Python. Now, if you know me, I love Python personally. But the reason we're going to use Python for this webinar today is because Python is an amazing language for test automation. It is concise, yet powerful. It has great tooling, great support, great frameworks. And it's easy for newcomers to testing and automation to pick it up quickly, as well as powerful for seasoned pros to do some real damage. So as a general purpose language, Python is just wonderful. And personally, I love to use it for test automation. So that's what we're going to use today. Our core framework is going to be the PyTest framework. That's one of Python's most popular test frameworks. For our web UI interactions, we'll model them using something called the page object pattern. Now, if you've done web UI test automation before, you probably know about page objects, but we'll cover them in detail. For the mechanics of browser automation, we'll use Selenium WebDriver, which is the de facto standard tool for this type of black box browser interactions with test automation. And finally, at the end, I'll show you how to extend our solution to handle multi-browser testing with parallel execution in the cloud using Lambda test. If we visualize our solution, it would look something like this, where on the left, we'll start with our Python tests. And our Python tests written in PyTest will be making calls to page objects, which inside those page object classes will make calls to Selenium WebDriver bindings, things like clicking buttons and scraping text. On the right side, we'll have our real live browsers, Chrome, Firefox, Safari, IE, what have you. In between the real browser and your test automation is the proxy. And that's what will communicate between your test automation and the browser. We'll start off by doing tests locally on one machine. In fact, I'll be running them on my machine. If you do local testing, you'll need a WebDriver executable that's compatible with your browser. So for example, if you're using Chrome, you'll need to install Chrome driver on your system path. Now, if you're doing remote testing, like we'll be doing with Lambda test, you can use a service like Lambda test where instead of doing local drivers, you make a request to a remote WebDriver and you'll get a session from Lambda test. Alternatively, you could also choose to set up your own Selenium grid. That's a lot of work. We're not going to talk about that today. But overall, this is basically how WebDriver automation works. Let's write a first test. As part of our solution, we're going to test the DuckDuckGo web application. I chose DuckDuckGo because it's free, its interface is very simple, and everyone knows how to use search engines. I always, always, always recommend writing your test steps before you ever start to write test code. Make sure that you're testing the right things. Make sure you understand your behaviors under test well, and you can explain them in plain language before you jump into the automation code. So with that in mind, let's write a basic search test together for DuckDuckGo. The steps are going to be pretty simple. The first step will be to navigate to duckduckgo.com. Once that page is loaded, our second step will be to enter our desired search phrase. We'll type it in and we'll hit enter, or we'll click that little hourglass icon. Now that's the core of the behavior. The next three steps are going to be verifying things that happen as a result. So the first thing we'll verify in step 3 is we'll verify that our query appears at the top of the results page. Step 4, we'll verify that the query appeared in the title of the page. And finally, the most comprehensive check, we'll make sure that the query somehow appears in all of the link titles for the returned results on the results page. I like to write my test cases not only in plain language, but using a language called Gherkin. Gherkin is simply given, when, then format for tests and for behaviors. It's very, very similar to the arrange, act, assert pattern, if you've heard of that. So my steps are basically what we just said. Given the DuckDuckGo homepage is displayed, when the user searches for Panda, then search result query is Panda, search result title contains Panda, and the search result links pertain to Panda. Like I said before, it's very, very helpful to write these steps out so that you know exactly what you're testing. And this also makes it easier to share your test cases and review them, even with people who don't know how to program or don't know test automation. Now, let's put these steps into PyTest. PyTest is a fantastic test framework. It's one of the most popular test frameworks in Python as well. As their homepage says, PyTest helps you write better programs. You can see in this gray box here an example of a PyTest test. Notice how it's just a simple function, def test underscore answer. And you use a basic assert statement to validate goodness or badness. Assert inc 3 = 5. You don't need a huge class. You don't need a bunch of extra methods in your class. It's very simple. It's very lightweight. It's very Pythonic. And so that's why we'll be using it today. Now, the purpose of this webinar is not necessarily to teach you all PyTest. I will be using PyTest as the framework for automation. But if you want to learn more about PyTest, and I strongly encourage you to do so, I can recommend these two books. Both of them are excellent. Python Testing with PyTest by Brian Ocken, as well as PyTest Quick Start Guide by Bruno Oliveira. You can also look up the PyTest docs online. They've been written very well, additionally. PyTest is not part of the Python standard library, but to get it, it's just a pip install away. If you know Python, you know pip is Python's package manager. You can install anything that's free and open source from pip. All you do at the command line is type in pip install PyTest, and you'll get the package. Once you install PyTest, let's add the test into the code of our project. From our root directory with PyTest, the best practice is to create a subdirectory called tests, and within that tests directory, to make a Python module that is prefixed with the name test underscore. If you look in the project tree, you'll see that whole path spelled out. If you use this path and this folder layout, then PyTest will automatically discover all of your tests when you go to run the tests. So it's really nice and convenient. Inside our test search py module, we're going to add a function called test basic DuckDuckGo search. Now you'll notice the entire thing is in comments, but what the comments have are all those gherkin steps that outline our test case, along with to-do tags. I like to use that as my metric as I go along and automate the steps of my test case to make sure everything is understandable and well documented, and also so I don't forget any steps. Once we have PyTest in place, it's time to start making browser interactions. And that's where we use Selenium WebDriver. Selenium WebDriver, as I mentioned, is the free and open source package that is the de facto standard for black box web UI automation. It has language bindings in all the major programming languages: Java, C#, Ruby, Perl, and also for Python. The Python package name is lowercase Selenium. What Selenium WebDriver will do is it will send web UI commands from our test automation code to whatever browser we're targeting. WebDriver can handle every type of web interaction. If you can click it, if you can type it, if you can see it, if you can scrape it, WebDriver has it all. Furthermore, I want to shout out now, we should use page objects or some other sort of design pattern to make our WebDriver calls for us. Because even though WebDriver is awesome, some of its commands can be rather low level. And so we want to make sure to abstract them out and really get better meaning out of that. And we'll see that shortly. Whenever I do Python web test automation, I can't always remember all of the names and the methods and the properties. So if you just Google Selenium WebDriver API Python, you'll probably land on this read the docs page. I just want to shout that out that this is a great website for Selenium documentation, and I highly recommend it as you pursue your own Python testing journey. To install the Selenium package, you install it the same way you did with PyTest. Pip install Selenium. Now, how do we set up the WebDriver? My strongly opinionated best practice is that each test should have its own WebDriver instance. One test, one WebDriver, one browser. The reason is keep things simple and straightforward, right? One test case should open up your app, do any login as necessary, interact with it according to the behavior under test, and then safely and securely exit, log out, and shut down. Doing that protects other tests and maintains test case independence. So if something were to go wrong in one test, other tests are not going to be affected. And additionally, other WebDrivers won't be affected. So always, always one test, one browser, one WebDriver. To set this up using PyTest, we use something called a fixture. If you're familiar with test frameworks, you are probably familiar with setup and cleanup methods. Fixtures are PyTest's take on setup and cleanup, but with an interesting improvement. What we'll do in our project tree, we'll create a module called conftest.py under our tests folder. That name is expected by PyTest for fixtures. And inside of it, we will put a method or a function called browser. We can name it whatever we want. And we're going to use a decorator, that's that @ pytest.fixture, so that PyTest knows that this particular function is a fixture. In this fixture here, we're going to do both the setup and the cleanup for our WebDriver. Now, this is going to be a local WebDriver, not one that's using Lambda test. I want to show you this because this is the simple basic case first. And then coming up pretty soon, I'll show you how to extend this to do remote WebDrivers with Lambda test. So let's keep it simple for now. Our fixture is 4 lines long. The first line is going to be actually initializing our WebDriver. So B equals Selenium WebDriver Chrome. What that will do is it will go to your local machine and it will try to look for Chrome driver on the system path. That's that proxy in between. And it'll launch it. It'll wake it up. Once that Chrome driver process starts on your test machine, it will then subsequently open up Chrome, the browser. So if you were to run a test at this point and freeze it here, what will happen is you'll see Chrome take over your screen. It'll pop up. It's magic. It's beautiful. The next thing we're going to do in this fixture is we're going to set an implicit wait time of 10 seconds. Now you may be wondering, what does that mean? As I mentioned before, one of the trickiest parts of web UI test automation is flakiness. And most flakiness comes from race conditions, e.g., is the web page ready for the automated commands you're sending to it? A lot of times you need to wait a few seconds for a page to load before you can interact with the element because the element won't exist yet. What this implicitly wait method here does is it tells your WebDriver, hey, before or every time you try to find an element, wait up to 10 seconds before you give up and throw a timeout exception. So that way you're implicitly handling that wait time. And it's a smart wait time. So if the element appears after 2 seconds, you're not waiting the full 10 seconds like you would with a hard sleep. Now, implicit waits are not necessarily always the best pattern. I strongly encourage you to do some research online on implicit versus explicit waits. In fact, that Python Read the Docs Selenium WebDriver site I showed earlier has a good article on there that I recommend you read. But for our simple purposes of our project, this will be sufficient. Finally, once I've set up and configured my WebDriver locally, what I need to do is I need to return it so my test can use it. And so that's that yield statement right there. So what it'll do is it will return a reference to my active WebDriver so the test can access it. That concludes the setup portion of my fixture. Now, this is where fixtures are really interesting because that's a yield statement and not a return. Everything above your yield statement in your fixture is your setup. Everything after the yield statement is the cleanup. Once a PyTest test finishes, it'll come back into this fixture after the yield and conclude with any subsequent steps. So that's why after my yield, there is one more line, and that's b.quit. We always, always, always want to safely, securely, and cleanly quit our WebDriver and our browser. Because if we don't, then there's a chance that those browser and WebDriver processes will continue running on your test machine. And then you get zombies. And zombies can lock system resources and choke your CPU and take all the memory. And I know Halloween's coming up in America, but in my opinion, zombies are bad. So always, always kill any potential zombie processes, clean up and quit safely your WebDrivers. So once we have our WebDriver set up, then we can start to use it for making those browser interactions. And the way we want to write and develop our browser interactions is with the page object pattern. Now, a page object is simply an object representing a web page or a web page component. And there are 2 primary parts to page objects. A page object will have locators for finding elements on a page, such as ID or class name or CSS selector. And page objects will also have interaction methods that will do the clicks, that will send the text, that will scrape the information, that will make choices in your dropdowns. And so a test case will essentially be constructing a page object and then making calls to those methods, which internally will use those locators. For the basic test that we outlined, we need 2 pages. We need a DuckDuckGo search page because we need to load the search page and we need to search for a phrase. And we also need a results page because we need to get the title, query, and link titles from that results page. Here, I'll share the code of the search page. This is basically the entirety of that module. It's fairly simple. It's fairly short, thanks to Python's conciseness. Whenever we make page objects, I strongly recommend to create a pages package separate from your tests directory. Here in my project tree, as you can see, I've made a pages package. It's a package because it has init.py, and I've put two new modules in there, search and results. So I'm showing you here search.py. My page object is a class, and it's named DuckDuckGo search page. If you look, it has some attributes. It has an init method as well as my interaction method. The init method is basically like a constructor in Python. It's not exactly a constructor, but analogous to Java or C#. That's kind of what it is. And what it does is it initializes this object. We're going to pass in a reference to the browser through dependency injection so that we can use the browser for our interactions. The first interaction method is to load the search page. And here I'm using the WebDriver API, self.browser.get my URL, where my URL is duckduckgo.com. Fairly simple. The search method is a bit more interesting because this shows how to use the locator. For my search method, I want to be able to search for any phrase, whether it's pandas or Python or platypus, whatever. The first thing I need to do when I search is I need to get the search input element, that search bar where the user types stuff in. To do that, I'm going to use the self.browser.findElement method. And the findElement method takes two arguments. It takes a locator type and a locator query. I've created an attribute called search input on my class, which is a tuple that has those two pieces. So I'm able to locate my elements using an ID locator where the ID is this name, search form input homepage. And I'm going to call it here. And I use this asterisk simply to expand my tuple elements into arguments positionally. That's all that does. I like this pattern for this because if I ever need to change my locator type, I can change it in one place rather than needing to change to a different method in my WebDriver API here. All that to say, if this locator is successful, it will return an object that represents that element that is active on the page. So I'm going to store that in search input variable. And then once I have that element, I can say search input send keys for my phrase plus the return key. What that would do is it will simulate the user typing out the text of that phrase and then hitting the return key to commit the search. So this is just a basic Python page object class. There are many, many ways to do page objects. Some people like to make a base page that is a superclass. Other people like to have shared methods and all that. There are goods and bads with all these kinds of styles. I just wanted to show it this way because this is simple and anybody can use it and understand it. Let's talk a little bit more about locators though, because I kind of glossed over how I got the ID and the query there. Locators are simply queries that find elements on a page. There are many, many ways you can find elements. You can try to find them by an ID, by their name attributes, by their class name attributes. If you need a little bit more firepower in selecting, you can use CSS selectors. You can also use XPath. I always recommend use the simplest locator possible that will uniquely identify your target elements. You don't want to have false positives. Element locators can return multiple elements. So if you're not careful with your locator query, you might get false positives. So watch out for that. When you're trying to find elements to write locators, you need the source code of the page under test. Personally, I like to use Chrome's developer tools to see the source code and figure out what my locators should be. So here's a screenshot of the DuckDuckGo homepage with DevTools open. If you want to open DevTools, anywhere on the page, right-click with your mouse and choose the Inspect option, and it'll open up this sidebar on the right. From there, you can hover your mouse over different elements on the page, and they'll highlight, as you can see in blue, and then link to the source code in the HTML. So here I did that for our search input, and you can see it's highlighted blue on the page as well as in the source code. And I know the text is really tiny and fuzzy here, but if you look at what's highlighted, you'll see it says input, and then it has an ID field where the ID is search form input homepage. IDs are easy when they're unique, so I just use that as my locator. So let's bring all the pieces together for our test case. We have our test steps, we have the fixture for the browser, and we have our page objects. So if I rewrite my test and fill out all those to-do lines, what we'll see is a completed test case in our test-search.py module. Some things to note here. In the signature of my function, I've added an argument for the browser. This browser here, this argument by name must be equal to our desired fixture. So notice that browser here is the name browser fixture. Anytime you declare arguments in a test function in PyTest, it will try to link them by name to any available fixtures. And if they do link, as this is the case here, then PyTest will automatically call that fixture and inject whatever is returned by the fixture into the test case. So that's how we can get our browser reference here for use. The next thing I do in my page object, or in my test case, is I instantiate my page objects. So I've created a search page as well as a result page. And I've continued to inject that browser reference so that the page objects have it as well. All of my to-do implementations are basically page object calls. So given the DuckDuckGo homepage is displayed, I'm going to say search page.load. When the user searches for panda, search page.search panda. Then the search query or the search result query is panda. Assert panda equals result page search input value. For the title, assert panda is in the results page title. And finally, for all of my search result links, I'm going to iterate over all of the titles returned by this result page, and then assert panda is in the lowercase version of each of those titles. So just like that, we have a complete test case as well as a complete test solution with PyTest and Selenium. And if all goes well, when you go to run your test at the command line, it'll look like this. One little green dot showing the test ran successfully, and then a banner saying your test passed. Nice. So now that we know the basics and we were able to run a test case locally, let's go to the cloud. As I said before, our current test solution can only run it locally. That, unfortunately, doesn't scale well. I'm locked into whatever browsers I can install and run on my machine. I can't easily do different version testing. If I'm running on one machine, I can't really test different operating systems. I'm stuck on the one I've got. So if I'm trying to do true cross-browser testing and multi-browser testing, I need more machines. And not only that, but I need a better tool. And that's where Lambda test can come in. With Lambda test, you can test any combination of browser, operating system, and version. It's simply WebDriver as a service. You want it, you request it, you got it. You also don't need to set up your own Selenium grid or your own device farm. It's hard enough trying to set up some sort of grid with desktop platforms, but then once you go to mobile, think about all those iPhones, all those Android devices, all the combinations there, plus the browsers on top of that. That becomes really, really difficult. So you can do huge at scale, multi-combo, desktop and mobile browser automation with Lambda test. The possibilities are endless. So whenever you approach this, I always recommend mitigate your risk with a matrix of test combinations. Decide what is important for you and your team to test, and then spray and pray. Another nice thing with Lambda test is you can also test in parallel. We can extend PyTest using the XDist plugin to let us launch multiple tests in parallel on the test machine. And then if we have Lambda test configured with enough concurrent sessions, we can just run those tests in parallel together with Lambda test. Parallel testing is basically essential if you want to achieve true continuous testing, because web UI tests are notoriously slow. Industry average is about 1 minute per web UI test. If you think about it, 100 web UI tests would take an hour and 40 minutes. 1,000 web UI tests would take about 17 hours. Those are very, very slow feedback loops. The only way to improve that and still get good test coverage is to run in parallel. So I strongly, strongly recommend that if you're doing serious test automation, then seriously consider doing it in parallel. And we'll see how Lambda test can help with that too. So let's flip over for the live code and the live demo. So here on my screen, I have the Lambda test dashboard open. This is just a basic dashboard. It shows you how many tests you've run recently, how many tests are currently running, what your service plan is. What I want to do though is I want to show you how to start with automating or running your tests with Lambda test. So I'm going to focus on the automation bar down here. The first thing we need to do when we're going from a local solution to a cloud-based solution with Lambda test, we need to configure our remote WebDriver options. We'll need to use a remote WebDriver class, and then we'll need to pass in a bunch of capabilities, things that will dictate what browser, what version, what operating system, all that. In my personal experience of using different platforms, it's a bit of a pain to do that. I'm not going to lie, because I have to plunge documentation, figure out exactly what this particular service provider needs, and then kind of piece it together myself. With Lambda test, they give it to you. On the automation page, if you go to help and you go to capability generator, it'll pop up with this page here. And what it does is it will automatically generate your capabilities for you. It's wonderful. So I can choose, am I doing desktop-based browser automation with Selenium, or am I using mobile with Appia? I can choose whatever programming language I want: Java, C#, PHP, Ruby, JavaScript, and my favorite, Python. I can configure whatever operating system I want. I can configure the browser I want. I can configure the version of that browser I want. And notice how over here, the capability set is dynamically updated. So for my testing, I want Windows 10 with Chrome, and I'll take the latest version. You can also do advanced configuration. Like, do you want to capture network logs? Do you want to capture screenshots? Do you want to capture the console? What's your time zone? I'm on Eastern time in the US, so I'm UTC -4, I believe. Do you want to record your video? All these things, your capabilities are dynamically generated, which is really cool. Then I'm going to copy that to my clipboard and take that to my automation project. So let me open up Visual Studio Code to show you my project. As I said before, this entire project is up in GitHub, so feel free to clone that on your own. My project is here. You can see I have my pages package. I have my tests folder. I even have some README and some other good stuff in here. But where I want to go is what I'm calling a config file. I like to put my capabilities into JSON config files that will get read into my automation as inputs. That way, I can more easily change my config file without needing to make changes to my code. That's a separation of concerns. It keeps things safe. And so here, I've put my capabilities into my config file. I have, with Lambda test, my username, my key. Don't worry, this is going to expire within a day, so don't you can't take it. And then I also put my WebDriver capabilities here, and they're going to be pretty much the same as what you saw in the config generator tool on lambdatest.com. The reason why I like to use JSON format for my config with Python is that the JSON module is a part of Python's standard library, and it can easily read JSON and write JSON with one line, and it reads it into a dictionary, which is a native Python data structure. So it's very, very easy to use. In order to read this config file, I'm going to need to write a new fixture. So I'm going to go over to my conf-test.py file. You're going to see some changes here. Before, that browser fixture was only 4 lines long. Now I need a little bit more stuff to make it work with Lambda test, but it's not too much. It's just a little bit. So first of all, I'm going to make a fixture that will read my lt_config file. The scope is session because I want to read it once per test suite, not once per test case. I only need to read this file once. And reading is fairly simple. With open my JSON file, I'm going to say json.load, that file pointer, and config here will be a dictionary. That's really all I need to do. But I want to be a little bit safe, so I'm going to do some basic verifications. I'm going to assert that my authentication is in there, that my username and key are in there. I'm also going to assert that a few basic capabilities are also in there, because I want to catch that before I run my tests. Because otherwise, catching it when it's too late, you're burning system resources. Finally, I'm going to return that dictionary from the fixture so that others have access to it. Next, I'm going to update my browser fixture. And here I'm going to declare my lt_config fixture. Fixtures can call fixtures. That's a beautiful thing about PyTest. That's why I love PyTest fixtures. So that way, the browser will be called once per test case. It'll simply get a reference to the config that was read in once before the test suite. And here's where the magic happens for remote web drivers. I'm going to concatenate my Lambda test URL that'll have my username and key, goes to the Lambda test hub. I'm going to get my capabilities, and one capability I'll dynamically add is the name of the test case, which comes from the PyTest request for the test case. So that way that'll show up in Lambda test. And then finally, I'm going to make my driver. Instead of doing Selenium WebDriver Chrome, I'm going to say Selenium WebDriver Remote. And I'm going to give it the Lambda test URL, as well as the capabilities that control all my options. I'm going to set an implicit wait that's a little bit larger than 10 seconds. I'm going to set it to 30 just because of network latencies in the cloud. I'm going to yield that driver so the test has access to it. And then finally, for Lambda test, I need to add a finalizer to my test request. All this will do is it will make sure that Lambda test knows when a test is passed or failed. This is fairly boilerplate code. It comes directly from Lambda test documentation. You'll also need to add an extra PyTest hook that also comes from Lambda test documentation so that some behind the scenes magical plumbing can happen with Lambda test getting your test results. Once I've set up my fixtures, my test is basically ready to go. What I've done here, I've added a parameterization to my test so that instead of just having one test for Panda, I now have 5 tests for different search phrases, and that gets passed in here. But nothing else in my test needed to change. That's pretty powerful, right? All I had to do was change the setup and the cleanup in the fixture, and the fixture got passed through. I did not need to change anything to my test case itself to get it to go from running locally to running in Lambda test. That's pretty cool. All of it was separated as a concern. My test case logic is unchanged. It's just a little bit of setup and cleanup. So with that all in place now, I can run my tests. I have my terminal here, and what I'll do is I will launch the tests here in my terminal, and then we'll flip over to Lambda test and see them running live. So here's my PyTest command. I'm going to use the -n option for xdist to tell it run my tests with 5 threads. So each one of these tests will be running in parallel. 3, 2, 1, go. So it queues it up, and then all the tests are running. If I flip back to Lambda test, then I can go to my automation logs, and we'll see 1, 2, 3, 4, 5. Those tests are actively running. And you can see for each one, test basic DuckDuckGo search, panda, penguin, polar bear, platypus, Python. What's really, really cool is you can actually watch the video recording in real time. So, well, the tests were so fast it already got done, but you can actually see it either in real time or ex post facto. You can see it here. It's recording the entire session of that test case. It did the search, it showed the results page, it verified things on the results page, and then it closed down the browser and the test is over. That's really cool. So we can see with my test sessions, it shows the platform, it shows the browser, it shows the version, things like duration time, whether it passed or failed. We can see things like not only the video, but are there any exceptions that happened? Let me do a quick refresh here. You can also see things like the commands that were run as part of the WebDriver. So this to me just blows my mind because it captures all of the back and forth through the proxy to your browser. So you can see things like, hey, you're trying to load your URL, you're trying to find an element, you are getting different kinds of elements, you're quitting the session. All of this is here. And at every step, you get the, excuse me, you'll get the different parameters for whatever that command was. And if appropriate, it'll capture a screenshot automatically. So you have this real trace to what was actually going on with your tests for debugging or for trying to figure out why something failed. You can also look at all the network traffic, all of those API requests going back and forth. You'll see the endpoint, the status, the method, all the information about it, how long it took. You can filter it by whatever type of request it was. Like, hey, am I looking for image files? Are they going particularly slowly? Everything is at your fingertips. You've also got, I'm just going to keep laying it on here. You've got your Selenium logs so that you can see everything going on. So this is just the raw log of all of that traffic specifically for the WebDriver. So this can help if you're not sure if args are getting passed through, if you need to confirm your browser version, if you want to see timings, boom. You've also got your metadata, everything that was true about the test from Lambda test perspective. You've got your input configuration, you've got your browser configuration. You can even download it if you like. So now let's say that instead of having these tests passed, what if these tests had failed? We never like failures, but bugs do happen. That's the whole reason why we test, because we need to flush the bugs before other people find them. What you can do with Lambda tests integrations are that you can actually open a bug report directly from a test case from this view. So if I had noticed that this test had been an X and had failed, I can come here and click on Create Issue. Now what I've done is I've linked my Lambda test accounts to my GitHub account. So what I'm going to do right now, I'm going to create a bug with one click. I'm going to go to our Lambda test Python web UI testing project in GitHub, which is the one that has the example code. And I'm going to, let's say I'm going to make an enhancement here. And I'm going to say, hey, add more test parameters. Let's give it a description. We should test search phrases for things other than animals. I'm going to create the issue. Boom. We're good to go. In Lambda test, you can look at all the issues you track over here in Issue Tracker, and you'll see here's the issue I just created, add more test parameters. It's got my name on it. It's got the configuration from the test that ran. And not only does it appear here, but it appears in GitHub. This is my account. this is my GitHub project. This issue was just opened. Add more test parameters, number 2. And it dumps everything from Lambda test so that you don't need the tedium of copying and pasting and potentially missing some information. So right there is amazing value add for Lambda test. You can also have other integrations. If you come over to the integrations tab, GitHub is not the only integration. You can integrate with things like Jira or Azure DevOps, any of your project management tools like Asana or Trello. Say you host in Bitbucket or GitLab instead of GitHub, all cool. You can have it send messages to Slack or Teams. You can integrate with CI/CD, choose your pick, Jenkins, Circle CI, Travis, Bamboo, whatever. And then there's also other platforms like different studios, different extensions, and all that. So it's out of the box. It's ready to work with a lot of things. And finally, one other thing I'll shout out. I know some organizations have great concerns about security, especially maybe in some pre-production environments before it goes out live. You can configure Lambda test to use a tunnel. So that way that you can make sure that all of your traffic to and from Lambda test is safe and secure, and it's not just public information. So that in a nutshell is how we can use, not only use Python and its various packages for effective web UI testing, but then to extend a Python test automation solution, to use a platform like Lambda test to really get the gold, to run tests in parallel, to run on any configuration we want, right? If I really wanted to, I could come back here, and instead of running in Chrome, I could easily run in, say, Firefox. You know, I can quickly spin that up and run with it. And so there's just so many cool things you can do with Lambda test. There's even more I don't have time to talk about, but for automation, I think this is pretty good overview. So let me get back to the slides here. And whoops, slideshow. Oh my gosh. Here we go, current slide. All right, I think with that, it's time for Q&A.
Great. That was great, Henry. Thanks a lot. This was really informative as well. There's a lot of learning for me as well. Great. So yeah, we have a question from one of our audiences here. I'm just kind of looking at it. Okay, so the question is, can Lambda test handle splash.credentials? Yes, we can handle splash.credentials. And there was one more question that one of our audiences asked was about how do we integrate from CI/CD pipeline. And we've also shared the documentation around the same as well on the chat. Okay, and I think we have, can you share a little access to the recording? Definitely, yes. We will be sharing the recording as well with you all post our webinar today. And we also have on YouTube. It was live on YouTube, so you'll also get a link to the YouTube as well.
Great.
Okay, I think there's a question for you, Andrew. Any tips on how to configure PyTest fixtures so you can configure whether or not to use Lambda or local to run your test? Which way do you recommend?
Sure. That's something that you would need to implement yourself, but it's not too difficult. What you could do is in that config file, you could just add some different options. So you could say, hey, maybe I have an option to say, how to run local or Lambda test. And then then in your conf-test.py module, when you read the config file, you could look for that option. And then from there, kind of, do an if else, if you're going to be running locally, here's your WebDriver. Otherwise, if you're running remotely, here's your remote driver going to Lambda test. It would be pretty easy to work into the code.
Great. And can we use Java with Lambda test? Yes, yes, you can definitely use Java with Lambda test as well. That's a Wait, I think so. We're almost close to having this. Great. So I think, yeah. And let me see if there's any other questions popping up. All right. Okay, I think, okay, we have one more question just saying,
Okay.
can you make PyTest tests dependent of each other and still use the parallel execution?
Ooh, I guess my answer to that question would be, why would you want to make tests dependent upon each other? To me, that's a testing anti-pattern. The purpose of test case independence is to make sure each one is individually safe. And also, it by a side effect that enables safe parallel execution without collisions. So if you have a situation where you're thinking that you need to make one test dependent upon another, what I would say is rethink your test case design. You may actually have written two test cases that ought to be one test case, just with multiple assertions. Or maybe there's a setup step that your second test case should have that is based on your first test case, rather than having hard dependencies.
I hope we've answered that. And one more question, what are the other IDEs we can use for PyTest framework?
Sure. So I was using Visual Studio Code, as you saw. You can also use PyCharm from JetBrains. PyCharm is an amazing IDE. There's a community edition as well as a professional edition. Community edition is free, professional edition is paid. I think you can use basic PyTest with the community edition. There's a couple other Python IDEs, but those are the big two that come to mind.
And we have one more question. Is JavaScript enabled on the remote browser? Yes, JavaScript is enabled on our remote browsers. Let me see if we have one more question. Okay, any suggestions that you have on the best reporting library? Andrew?
Best supporting library for...
Yeah, for reporting.
Oh, reporting, I'm sorry.
Yeah.
PyTest has a plugin called PyTest HTML that will give you pretty print reports, graphical things, charts, and all that kind of stuff. Most IDEs, or not IDEs, sorry, most continuous integration tools like Jenkins or Travis or TeamCity will also do just kind of like test reporting and history trends and all. Most of those will expect a JUnit XML report format. But what you can do with PyTest, there's actually like a -JUnit XML or some sort of option in PyTest from the command line that will make PyTest generate that same report, so that you can have the PyTest results come in a JUnit XML format that can then get sucked into your CI tool and just print pretty like that.
Right, and just to add into that, so Lambda tests have extensive integration with CI/CD tools like TeamCity, Bamboo CI, Circle CI, and we also have our APIs for you to readily pull up the data into any of your reporting framework. Now, right, there's another question. Can I schedule builds at Lambda test? No, you cannot schedule. So you would be using the CI/CD tool to do that. Great. I think we overshot the time. So great. So, I want to thank everybody out here who have joined this webinar, and thanks a lot, thanks a lot, Andrew, as well. Kind of taking time to take a deep dive into how to use Python. So, guys, you can give it a spin, and you can also see some sample GitHub from the webinar we had. You can give it a spin on Lambda test. You also get free 200 minutes of automation testing on our platform, so feel free to sign up. And also, we have our upcoming webinar just before the holidays, Thanksgiving holidays. So we are basically going to have going to give you a brief overview of how we can expand your cross-browser testing with Lambda Test and Selenified. And Jeffrey Payne is the CEO of ฆığᴜ, and these guys are the makers of Selenified. So please feel free to register the same. And yeah, thank you again for taking your time today for the webinar, and we truly appreciate it. Thank you so much, guys. And Andrew, thank you so much again.
Oh, thank you. It was a pleasure. I was glad to be here. Thanks for inviting me.
Glad you made it time. It was great follow-up, with you to get on board. You're a busy guy. But thank you again. All right, guys. Thank you so much to all our audiences.